In today's episode, you will learn how to make an IoT-based patient monitoring system using Node MCU ESP826655 module, Arduino, HC-05 Bluetooth module, and cell phone applications. This is an advanced level project and is entirely different from all the existing patient monitoring systems available on YouTube. As you can see in this project, two different cell phone applications are used for monitoring the patient temperature and BPM. With the help of this application, the patient BPM, temperature in centigrade and Fahrenheit with 2 decimal points precision can be monitored from anywhere around the world. With the help of this application, doctor can monitor the patient in real time from anywhere so far the internet connection is available. While this application can be used by the family members to wirelessly monitor the patient temperature and BPM, I have a separate video on the Android cell phone application designing for the Bluetooth module. I will provide a link in the description. This project is designed in a way that it can be easily modified by anyone and most sensors can be interfaced. To accommodate most sensors, I'm using Arduino and Node MCU ESP8266 Wi-Fi module together. Without any further delay, let's get started. The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. This is the complete circuit diagram designed in Ksoft Eagle 9.1.0 version. If you want to learn how to make schematic and PCB, then watch my tutorial. The link is given in the description. Let's start with the DS18B20 digital temperature sensor. As you can see, a 330 ohm resistor is connected between the VCC and data wires. You can also use a 4.7K resistor. The VCC is connected with 3.3 volts. The data wire is connected with the Arduino's digital pin 4, while the ground is connected with the Arduino's ground. The VCC pin of the pulse sensor is connected with the Arduino's 3.3 volts, but you can also connect this with 5 volts. The S pin of the pulse sensor is connected with the analog pin A0, and the ground pin of the pulse sensor is connected with the Arduino's ground. This power supply is based on the famous LM7805 voltage regulator. J1 is the female power jack, and this is where we connect a 12 volt adapter or battery. Two 470 microfarad capacitors are connected at the input and output sides of the voltage regulator. A 330 ohm resistor is connected in series with a 2.5 volt LED. This is a current limiting resistor. The output of the voltage regulator is connected with the VN pin of the Node MCU ESP826655 module, and the ground is connected with the ground. SV1 and SV2 are the female headers. The HC-05 or HC-06 Bluetooth module is powered up using 3.3 volts from the Node MCU module. The ground of the Bluetooth module is connected with the ground of the Node MCU module. Make sure you connect the ground of the Node MCU module with the ground of the Arduino as well. The TX and RX pins of the Bluetooth module are connected with the Arduino's pin number 7 and pin number 8. Pin number 7 is the RX while pin number 8 is the TX, which will be defined in the programming. This is the final Node MCU ESP8266 Wi-Fi module power supply circuit board. I have a separate video on how to design the PCB, how to place an online order. You can find link in the description. I also have a separate video on how to change the name of the Bluetooth module and how to change the password using AD commands. This tutorial explains everything you need to know about the HC-05 or HC-06 Bluetooth module. This is the pulse sensor which I'm going to use in this project for measuring the heartbeats. I personally don't like this sensor and I'm searching for another sensor, but right now this is what I have for now. If you have never used this sensor, then I highly recommend you should watch my previous 2 tutorials on the pulse sensor, which explains everything. The Bluetooth cell phone application is designed in Android Studio. I have a very detailed tutorial on how to design your own Android cell phone application. The APK file of this project can be downloaded from my website. First of all, open the Blink application. Set the project name as IoT Patient. Click on the Choose Device and select Node MCU. Make sure you set the connection type to Wi-Fi. Then click on the Create button. An authentication token will be sent on your email ID, which will be then used in the programming. Simply copy and paste it in the programming. Click anywhere on the screen and search for the gauge and add it. Now click on the gauge and set the name. Click on the pin and select Virtual Pin V3. Set the maximum value to 50. Change the font size. Click on the push button and select 1 second. Now again click on the screen and add another gauge. Follow the same exact steps but select Virtual Pin V4. Now again click on the screen and this time search for the LCD widget and add it. Select the input type as Advanced. Click on the pin and select Virtual Pin V5. That's it. Our application is ready. In this project, 2 programs are used. One program is written for the Arduino while the other program is written for the Node MCU ESP8266 module. Let's first start with the Arduino programming. Before you start the programming, first of all, make sure that you download all the necessary libraries. These libraries are available on my website. Check link in the description. The Arduino communicates with the Node MCU module and Bluetooth module using serial communication. As you know, in Arduino we have only one serial port which is available on pin number 0 and pin number 1. This is the Arduino's default serial port which I'm going to use only for the debugging purposes. To communicate with the Node MCU module and Bluetooth module, I defined 2 serial ports with the names Node MCU and Blue. The Node MCU module is connected with the Arduino's pin number 2 and pin number 3, while the Bluetooth module is connected with the Arduino's pin number 7 and pin number 8. The pulse sensor is connected with the analog pin A0 of the Arduino. These lines are already explained in my previous pulse sensor based projects and DS18B20 waterproof temperature sensor based projects. I simply combined the 2 programs. The links are already provided in the description. In the white setup function, I activated the serial communication. The rest of the functions are exactly the same as explained in my previous tutorials. Then starts the while loop function. The beats per minute value is stored in the variable my_bpm. These instructions are used to read the temperature in Celsius and Fahrenheit. The temperature values are converted into string values with 2 decimal points precision. Finally, I created a complete message consisting of the temperature and BPM values. Then these values are sent to the serial monitor, Node MCU module and Bluetooth module. Now let's discuss the Node MCU programming. These libraries are available on my website. Check link in the description. If you are using the Node MCU module for the first time, then I highly recommend first watch my getting started tutorials in which I explained how to install the Node MCU board and how to write a very basic program to control an LED and how to monitor the LDR. These tutorials will help you how to use a Node MCU module for the first time. This is exactly the same program which I used in the IoT based weather station monitoring system. In this program I did a few changes. I defined a virtual pin for the LCD widget and increased the number of variables from 2 to 3. Edit these instructions which are used to display the BPM value on the LCD widget. This is the same function I have been using in all of my Arduino plus Node MCU projects. This function is used to split the string message using comma as the delimiter. So that's all about the programming. The circuit diagram and programming can be downloaded from our website. I have already uploaded these programs. Let's watch this project in action. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.